Hey guys, it's Cameron here, aka the Currency Kid. Today I want to talk a little bit about sharding in regards to blockchain. This video isn't going to be crazy technical. As you can see, I just have about 6 slides here, mostly just to make it very visual, just so people can get a basic understanding of what sharding is. Sharding's been around for a long time. Just in the general tech space, it's pretty new to blockchain, so a lot of projects are trying to figure it out, implement it, and a lot of it hasn't really been proven on a large scale. So it's something that definitely, it's 2019 now, 2019, 20, and 21. It's definitely going to become a little bit more mainstream as far as understanding is concerned. And yeah, we'll see exactly how it can contribute to scaling. So, just a written definition of sharding. Sharding is a type of database. Sorry, let me restart. Sharding is a type of database partitioning that separates very large databases into smaller, faster, and more easily managed parts called data shards. So, what problem is sharding trying to solve? It's trying to solve the scaling problem. So, let's take a project like Ethereum. I'll use them as an example. Ethereum probably has, a couple thousand nodes on their network, on their blockchain. It's one blockchain, the Ethereum network, with these thousands of nodes and miners. And every single node has to verify the transactions coming in that are being broadcast onto the network. They have to verify them, they have to create new blocks, and then every single node on the network has to store a copy of the blocks and have a copy of everything that just happened right now. So you can see that thousands and thousands of these nodes or computers having to verify everything that's happened and everything that's happening now. You can see how that would be very slow, and it would be very hard to have thousands of transactions per second being verified through every single node across the blockchain. That's why it's been hard to scale Ethereum past. I think right now it's 15 transactions per second, just because simply, once again, due to the fact that every single node has to verify everything that's going on. That's a lot of information at one time. So, a way to visualize sharding. Once again, you're partitioning, and what you're doing is you're breaking up the chain into many different chains. So this just represents a blockchain, a series of blocks. Here you have a main chain, and then you have these different side chains. So you're taking a blockchain, and really you're making several different copies of it. So on a regular main chain, just take the Ethereum network for an example. You have your blockchain, and you have your thousands of nodes or computers. Let's just say these 4 computers represent all the thousands of nodes on the network. Every single node has to verify the transactions that are coming in. They have to create new blocks, store copies of everything that's happened so far on their computers, and then store the new block that came onto the network. With sharding, every single block or blockchain has its own set of nodes or miners that are verifying all the transactions that are coming in the network. So instead of thousands of transactions coming into this one chain with all these nodes trying to verify the blocks, verify the transactions, and keep up with what's happening and make copies, that's happening on several concurrent running blockchains. So, for example, you may have the Ethereum main chain right here. You may have transactions taking place on there. And then on this chain, you may have one application or a couple different applications running there. On this chain over here, you may have a decentralized exchange running. On this chain over here, you may have certain types of smart contracts and etc. Excuse me. So really, instead of all this information being congested on one chain, it's being broken up into many different chains. I think Ethereum's saying they want to have, I think it's 1,024 or 1,000 different chains. So, if each chain could do 15 transactions, there's 15,000 transactions per second potentially, compared to just the 15 on the one chain that's happening now. So I hope that gives you guys a good visual. Um, yeah, once again, every blockchain has its own set of nodes that are verifying what's going on. Um, and something that they're trying to do as well is make it so that the nodes on each network aren't locked in. They're going to be randomized. So, for example, let's say there's 21 nodes on this blockchain, 21 nodes on that blockchain, and 21 nodes for that blockchain. If it's known that this blockchain always has the same nodes, it could be pretty easy for someone to try, or not easy, but it could be possible for someone to try to get a hold of half of these nodes on this same network to take over this one and have a 51% attack. But if, the two of these next transaction are over there, or next block, if two of these are over there on the next block and two of these are over there on the next block and it's randomized, it's pretty hard to have a 51% attack and know which nodes to take over on one single network if they're being randomized. Uh, and I mentioned the number 21 nodes. So for example, right now the Ethereum network has several thousand nodes running on one network. Um, if every single one of those thousands of nodes has to verify what's going on at all times, that's a lot of nodes that have to keep up with the information. But if you have thousands of different chains and all the nodes are randomized, you may be able to get away with only having 21 nodes on each network. So 21 nodes trying to verify blocks and store copies of the blocks. That's going to run a lot faster than several thousand. So these shards or sub blockchains are going to be able to run much faster than one blockchain that has thousands of nodes, because it only has maybe 21 nodes. So it can process and verify these faster, get them through the network, and secure it on the blockchain a lot faster than just one blockchain. Imagine a bunch of water coming through. If there's only one pipe, that all the water's running through, there's going to be a backlog. But if there's 1,000 concurrent pipes where all the water is coming through, transactions are going to be able to flow way faster through, um, and get a lot more done, and hopefully scale. And then in the future, there'll be ways that Ethereum network and different networks are working on so that these blockchains can relay information back and forth to each other. Say, for example, there's a game on one of these side chains. The main chain doesn't need to know everything and every single step happening on the game. But let's say this game is complete, there's a winner and a loser. There'll be a way to relay information back to that chain, or even get tokens from this chain back to that chain. So I hope that gives you guys a good visual. Once again, to summarize, sharding takes one blockchain and basically makes it into several other different blockchains. Each blockchain has its own nodes that are confirming transactions and creating blocks on that specific chain. And yeah, guys, this will hopefully be able to solve some scaling issues. So I hope this visual helped you guys out. Um, and yeah, let's see if Ethereum can implement this and if it can help them reach their goals and move the space forward. Thanks for watching.